Alright, welcome back. We're going to do 12 and 13. There is a lot of work for this one, so this might be a long video, but it is just all on page 3, so let's start with it. Here we have to divide a polynomial with a binomial. Since our binomial just has an x, no coefficient on the x, we actually have two ways here. We have our long division and our favorite one, our synthetic division. So first let's do long division, which almost nobody did on the test when we originally assessed ourselves on this. Most of us did the synthetic one, which I'll do that right after we do long division. So to set up our long division with polynomials, we still use the same way, and I'm going to try to write small here because I can't extend the screen. So we have x plus 3, and then our division, and then 4x cubed plus 19x squared plus 25x plus 13. Alright, so now when we're with this, just like in long division, we have to figure out what value can we multiply the x by to also get 4x cubed. I know it has to be a 4, so I get a 4 down here. I already have an x here, so I only need an x squared on top. So when I do that, I get this x to the cubed. Alright, that means that when I end up subtracting, I will get a 0 down here. So I still have to figure out what goes next. So now I do our 4x squared times the 3. So I get 12x squared. Remember, we're subtracting, so I'm left over with plus 7x squared. Alright, now moving on, I'm going to bring down the next term, so 25x. And now I have to think to myself, what can I multiply x by to get to 7x squared? And here it will be 7x. So now if I multiply this, I'll get 7x squared. And then 7x times 3 would be 21x. So we are subtracting, right? And we can show that by doing parentheses and a subtract sign. We are subtracting both terms from the terms above, so we end up with 4x, and then we bring down our last term, which is a 13. So now we have, what do we multiply x by to get to 4x? So that's another 4. If we do that, we don't have to add any x's here, so we get 4x plus 12. Again, we are subtracting, so we get this 1 left over. I don't have anything else to do, so this is actually our remainder, just like how we learned how to do division in the first bit of elementary school. So to write our answer, they want fraction form. So we usually on our work and on our test, we had to say 4x cubed plus 19x squared plus 25x plus 13, and we are making that as a fraction by what we're dividing by. Alright, and then our answer is 4x squared plus 7x plus 4, but our remainder is not a part of our answer, and that's still with our denominator. On the test, your answer choices on the multiple choice won't include our setup, but just what the results we got when we did our division. So this is what you're looking for on the multiple choice part of our test, and we'll go over how to use our synthetic division. So again, we were doing 4x cubed plus 19x squared plus 25x plus 13, and we're dividing that by x plus 3. You guys said you were pretty good, you felt pretty confident about synthetic division, but one really important step here is we have to take our binomial and we have to write what our, not the 3, but we have to actually write what our x-intercept on our graph would be. So here we're basically saying x is -3 on our x-axis, so that's what we're going to synthetically divide by. So remember, we put -3 in the little house, and then we just take the coefficients down from our polynomial. So we have a 4, we have a 19, we have a 25, and we have a 3. Next up was to skip a row and then jump down, and what we do is we bring the 4 down, and then we take the 4 and we multiply it by the negative 3, so we get negative 12. Again, bring the 4 down, multiply the 4 by the negative 3, that's how we get the negative 12. And now we add the numbers together, which is different from what we did in the other method. We add the numbers together and we get our 7. Again, we take the 7, multiply by the negative 3, so we get negative 21. And again, we add it up, which is different from the other method, and we get our 4. So we have our same coefficients, but we still have this last step, which is going to be, and I did copy this problem wrong, this should be plus 13, not plus 3. So we have 4 times negative 3, which is negative 12, and then we get a 1. So this is where synthetic division is a little bit weird. You have to remember what to do with all this information. All right. 1 is still our remainder. Our last number is our remainder. The next term has no x's. The term to the left of that has 1 x, and the term to the left of that has 2 x's. If we continued on, we would just add 1 more to the coefficient each time. So our answer here is 4x squared plus 7x plus 4 with our remainder of 1. And we still have to remember that we put that remainder over what we originally divided by, which is that x, our x plus 3. All right. So just like on the other method, this would be the answer that we see on our multiple choice part of the test, even when it says in fraction form. All right, so that was dividing polynomials. Now we have to talk about how to find all of our zeros. In this method, we are still going to use division, and I'm just going to use synthetic division because it just takes up less space. So with this is when we had to graph it, find what possible answers it could be, take information out, and then usually ended up either finding complex answers or just really messy answers for this. It did give you a clue. It said exact answers must be simplified radicals. No decimals allowed for this question. All right. So first, let's try to see what our possible answers might be. We had this helpful theorem which said our rational zeros, all right, were our factors of our, and I kind of put this in term of a quadratic, but our factors of our linear term c divided by our factors of our leading term a. So here we're doing factors of 36 divided by our factors of 1. So 36 has a ton of factors, which would be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 9, ran out of room because there's so many, plus or minus 12, plus or minus 18, plus or minus 36. And all of those would be divided by plus or minus 1. So our answers for all of our clean-looking zeros would be positive negative 1, positive or negative 2, positive or negative 3, positive or negative 4, positive or negative 6, positive or negative 9, positive or negative 12, positive negative 18, positive negative 36. All right, for this one, I do want to use a graphing calculator. So you're going to have to forgive me that I'm going to switch over to the camera of my iPad. I haven't tested this yet, so let's see if it works. All right, I'm going to graph our polynomial, and I'll just show you the graph that I get in here. So remember, we graphed x cubed minus 14x squared plus 45x minus 36. All right, so let's see how well this is going to work. Go to my camera. Oh, camera's down here for some reason. This is very odd. Alright, so this is our graph that we would see right away on our calculator. We do see that we have a couple of x-intercepts. They're not easy to tell what they are. I would always advise you to go to our table, which remember we're going to click not just that button, but second that button, second the graph button, Alright, and this would be our table. We can scroll up and down and see until we get to a 0. The only 0 we have at 3. And that would be the only rational, aka a fraction, and we saw that on our work inside of our notes. If we go back to our graph, though, we know we have 2 more real zeros because it does actually cross the x-intercept 2 more times. So we will need to do a little bit of work to figure that out. So let me go back to our notes now, and we'll talk about how to do this. Unfortunately, I ran out of space here, but remember we said one of our roots will be x equals 3. So we did all of that work to know for sure x is 3. Usually, sometimes we got fractions here, and that's why this theorem was helpful. But for us, we don't really have to do it. So we said our x-intercept was 3. So to do synthetic division, now we take our coefficients. So we got 1, then a negative 14, and then a 45, and then a negative 36. So for synthetic division, we copy down the 1, multiply the 1 with the 3, and put that in. Now we do negative 14 plus 3, so negative 11, and we keep that process going. So 3 times negative 11 would be negative 33, so add those two together, we get 12. Do that process one more time, and we get 3 times 12 is 36, and we get a 0. When we were finding zeros, we want a 0 at the end. That's good. That means we actually did our work correctly. So now we have to write this equation as a quadratic. So remember we said this term is linear, so that's just a 12. The next one would have 1x, and then the one all the way to the right, the left would have 2x's, so x squared. We want to try to see if we can do this the easy way, which is using, just try to factor it. Here we would want a number that would multiply to positive 12, but add up to negative 11. If it was a different number, we might be able to actually find the factors here, but we can't. So we have to use our quadratic formula. So here, that's when we had those videos for extra credit to memorize our quadratic formula. For me, I still love the one where it says, there once was a negative boy who couldn't decide to go to a radical party. The boy was square, so he missed out on 4 awesome chicks, and it was all over by 2 a.m. So now let's plug in our information, negative 11, plus or minus the square root of negative 11 squared minus 4 times 1 times c, which was 12 here, all over 2 times a, which is 1. So let me go up here just so I have a little bit more space. So I get 11 plus or minus, and inside the radical we'll get 121. And once we do a little bit of math, we'll get minus 48 all over 2. So we'll get 11 plus or minus the square root of 73 all over 2. There is no way to clean up that radical, no way to simplify it. 73 is a prime number. We cannot simplify this. So that is our answer. So when we write out our final answer, we're going to use set notation. So remember, our first one was 3. Our second one, we can just take the plus part of this, put it over 2, and then the last one will be minus square root 73. Sorry for losing space, and then we would have another parenthesis. Again, I'll just do this on another slide. We have 3. All right. We also have 11 plus square root 73 over 2, and 11 minus square root 73 all over 2, and then end with a nice bracket. That is the end of the third page. I will continue on another video.